Well, hello and welcome to this instructional video. Please make sure you have handy a copy of the assignment How to Calculate Formula Mass, and that you have a copy of the periodic table of elements and a calculator and something to write with. What we're going to look at today is how do you calculate how much does one piece of a substance in chemistry weigh, its formula mass, by counting all the atoms of the elements that are in a substance, using the periodic table to find their mass, and a calculator to total the mass of all the atoms of the elements. What we'll do is we'll work on two examples on the front of this assignment and one example on the back, and then there are some problems that you can work out on a separate sheet of paper. Okay, so looking at the examples. The first example that we'll do is for the substance water. So we'll start with its formula, chemical formula for water, H2O. And there are 5 easy steps. We'll keep track of each of the steps using this template. The first step is to list the elements that make up the compound. So hydrogen and oxygen. You can tell which ones are the elements because they always start with a capital letter. The second step is to count how many atoms there are of each element. Hydrogen is a subscript of 2, so there's 2 of them. Oxygen doesn't have a subscript, so it counts itself. It means there's just 1 of them. Now the third step, this is where you need the periodic table. Look for the elements on the periodic table, hydrogen and oxygen. They're listed with 2 numbers. The whole number is the atomic number, which counts parts of the atom, its protons in the nucleus and the electrons. We're going to look at the atomic mass. That's the number with a decimal point. And we'll use that when we do these calculations. For hydrogen, the atomic mass is 1.0080, and the unit is the atomic mass unit represented with the letter U. For oxygen, it's 15.999 atomic mass units. When you found the elements, how many atoms there are, and their atomic masses, then we multiply them. And we write down the answer. Now, since we're going to use measured quantities in a calculation, we have to pay attention to the significant figures rounding rules. So we'll start by multiplying 2 times 1.0080. Now the calculator is going to give you an answer that has maybe too few or too many significant figures, so we're going to round to the correct number of significant figures. In the measured quantity here, there are 5 significant figures, and the calculator only gave me 4, so when I write down the answer, I'm going to add back that missing significant figure, 2.0160. Now that has 5 significant figures. This counted quantity here doesn't have significant figures. It's an exact number. Then oxygen, 1 times 15.999, that's easy, 15.999. And then the last step is to add these together. So I'll take my 2.0160 plus 15.999, and the calculator says that it's 18.015. If I had brought down this 0, if I had done it without the calculator, I would have had a 0 there. The rounding rule for adding and subtracting is to chop off your answer after the fewest decimal places. There are 3 places after the decimal point in this value, and there's 4 after in this value. So when I write my answer, I'll keep only 3 after the decimal point, 18.015 atomic mass units. That will be the answer. 1 molecule of water has a mass of 18.015 atomic mass units. It's an incredibly tiny mass, much too small to mass on a balance. But when we look at how to count things using this number, we'll change that unit into one that you can measure on the balance. So 5 easy steps. Let's try the next example. The next example is for copper nitrate. The formula says Cu parentheses NO3 subscript 2. Copper nitrate. List the elements first. You can tell which ones are elements because they start with capital letters. Copper, nitrogen, oxygen. Then count their atoms. Copper doesn't have a subscript, so it counts itself, 1. The subscript outside the parentheses here distributes into the parentheses, counting 2 nitrogens, and 2 times 3, 6 oxygens. Then find their masses on the periodic table. Here's copper with 63.54, and nitrogen with 14.007, and oxygen 15.999. You'll see oxygen in a lot of compounds. It's a very reactive element, so you see it all the time in these formulas. So what was copper again? 63.54 atomic mass units. Nitrogen, 14.007 atomic mass units. Oxygen, 15.999 atomic mass units. Next step is we'll multiply them. Now the first one, of course, is easy because it's just 63.54 units. The next one will multiply 2 times that, 28.014 atomic mass units, and 6 times 15.999 equals 95.994 atomic mass units. I'm checking my significant figures. There were 4 significant figures here, 4 in my answer, 5 here, 5 in my answer, 5 here, 5 in my answer, and the counted quantities don't contribute significant figures. Now I'll add these all up. 28.014 plus 63.54, and I'll write down my answer. Calculator says 187.548 units. Now when I add or subtract, I have to look for my weak link in my chain of calculation. And when you add or subtract, the rule is to chop off your answers after the fewest places after the decimal point, which in this case is 2. So when I chop off this 8 before it goes away, it's going to round up that 4 to a 5. 187.55 atomic mass units. That's the mass of one formula unit of the compound copper nitrate. So all we're doing is we're taking the formula, finding how many atoms there are of all the elements, using their atomic mass to find the total mass of all the atoms of all the elements in the compound. Alright, let's do one more example. Next example on the back of the paper is for calcium phosphate. Okay, calcium phosphate, Ca3PO4 2. Calcium phosphate. You will find this one in the pipes that bring water into your house. It builds up over time, and if you have a lead-based pipe, it will protect your water from exposure to that lead. It builds up like a crust, a protective crust. Okay, so elements start with capital letters. So I'll identify calcium and phosphorus and oxygen, and then we'll count how many atoms there are of each element. There are 3 calciums, there are 2 phosphorus, and there are 8 oxygens. Then we'll look for those elements on the periodic table and find their atomic mass. Calcium, right here, is 40.08, and phosphorus is over here. It's 30.974, and oxygen, as always, we'll see that one frequently, 15.999 atomic mass units. Then we'll multiply. Now when I multiply these, the calculator is going to give me an answer that I can't keep. The calculator is going to give me 5 significant figures. And since this only has 4 significant figures, I'll only keep 4 significant figures in my answer. So instead of 120.24, I'll keep 120.2. The 4 doesn't round up to 2 when it goes away. Then the next one, I'll say 2 times 30.974. And since I have 5 significant figures in this measured quantity, and the calculator gives me 5 significant figures in the answer, I'll keep all 5 of those significant figures, 61.948 units. And then the last one, 8 times 15.999. Calculator gives me 6 significant figures in the answer, but since this measured quantity has only 5, I'll keep 5 for my answer. So I'll keep 127.99, 127.99 units. Now I'll add them all up. 127.99 plus 61.948 plus 120.2. Calculator says 310.138 units in my answer. But since I'm adding, I'll use the significant figures rounding rule for adding. Look for my weak link, the one with the fewest places after the decimal point, which in this case is 1 after the decimal point. So that's where I'm going to chop off my answer. When I take away the 3 and the 8, this 3 does not round up to 1, so I leave my answer at 310.1 units. That's the mass of 1 formula unit of the compound calcium phosphate. So it's a pretty easy process, 5 easy steps. First, listing the elements, counting their atoms, finding their mass on the table, multiplying and adding. 5 easy steps. Make sure to use significant figures rounding rules. If you're not comfortable with those, then at least get it set up and calculated. The calculated answer here, that's like cake. And this answer that's rounded, that's like frosting. And you know, cake is still good without frosting, as long as you get some milk. We'll take a look at these problems when you bring them to class. And if you have any questions, I'll give you some feedback on that. Keep an eye out for the next video in the exciting series of chemistry demonstrations, how to do calculations.